Deep in the Irish countryside, in pubs and family gatherings, people still whisper about them. The Black Irish. Dark-haired families with olive skin and Mediterranean features that seem borrowed from southern Europe. Their origins have puzzled historians for centuries. But are they even real? The most popular explanation involves the Spanish Armada of 1588. Picture 130 Spanish ships sailing toward England, only to be scattered by storms and English fireships. According to legend, survivors washed ashore on Ireland's rugged coastline, married local women, and passed down their distinctive looks through generations. Other theories reach even further back. Some claim ancient Phoenician traders left genetic traces. Others point to mysterious North African merchants who supposedly arrived millennia ago. Today, we're using cutting-edge DNA analysis to solve this centuries-old puzzle. The results reveal a story far more extraordinary than Spanish shipwrecks or Mediterranean merchants. The real genetic history of Ireland spans 6,000 years and connects this small island to the epic migration story of all Europe. In 2017, geneticist Giampiero Cavalieri and his team at the Royal College of Surgeons in Dublin accomplished something unprecedented. They created Ireland's first comprehensive genetic atlas using DNA from 536 Irish individuals, whose families had lived in the same regions for generations. This research built on the People of the British Isles project, which had already mapped genetics across rural England, Scotland, and Wales. The Irish study went deeper, examining specific genetic markers that could trace ancestry back thousands of years. The technique works by analysing variations in long DNA segments. Recent genetic mixing creates longer similar segments between groups, while ancient ancestry appears in shorter fragments. Think of it like cake batter with distinct ingredients. One stir shows clear layers, but 50 stirs later requires careful analysis to separate the components. The results completely overturned traditional assumptions about Irish ancestry. The genetic signatures didn't follow expected north-south or east-west patterns. Instead, they aligned perfectly with Ireland's 4 ancient kingdoms: Connaught, Leinster, Munster, and Ulster. Ireland's genetic story begins 6,500 years ago in Anatolia, modern-day Turkey. This wasn't random migration. These were farming families carrying the Neolithic revolution itself across Europe. Around 6000 BC, Anatolian farmers began one of history's most important journeys. They followed 2 main routes westward, up the Danube River Valley into Central Europe, and along the Mediterranean coastline toward Western Europe. These weren't nomadic wanderers. They were agricultural pioneers carrying domesticated wheat, barley, sheep, and cattle. The migration took millennia. Farming communities reached France around 5000 BC, crossed to Britain by 4000 BC, and finally arrived in Ireland around 3750 to 3500 BC. In 2015, scientists analysed the genome of a Neolithic Irish woman who lived 5,200 years ago. Her DNA profile most closely matched modern populations from Spain and Sardinia, regions still largely descended from those original Anatolian farmers. These newcomers transformed Ireland completely. They cleared forests, planted crops, and domesticated animals. Most remarkably, they built New Grange, the massive passage tomb that predates both Stonehenge and the Egyptian pyramids. This monument required sophisticated astronomical knowledge and coordinated labour from hundreds of people. Around 2500 BC, Ireland experienced one of the most dramatic population changes in European history. New people arrived carrying bronze technology and genetic signatures from the Pontic Caspian steppe of Eastern Europe. These Belbeca people descended from the Yamna culture, nomadic herders who had domesticated horses and mastered metalworking. The Yamna weren't just technologically advanced, they were the original speakers of Proto-Indo-European. the ancestor language of English, Irish, German, Sanskrit, and dozens of other languages. The genetic evidence is staggering. Between 2400 and 2000 BC, Bell Beaker migrants replaced approximately 90% of Ireland's existing Neolithic population. This wasn't gradual mixing. Archaeological evidence shows the replacement happened within just a few generations. We can see this transformation in actual skeletal remains. Compare Rathlin man from Northern Ireland and Beaker man from Yorkshire with earlier Neolithic individuals, like those from the Anna burial site. The physical differences are dramatic. Different skull shapes, body builds, and genetic markers for hair and eye colour. The Bell Beaker people brought more than bronze technology. They introduced new burial practices, pottery styles, and social structures. Most importantly, they carried genetic signatures that closely match modern Scandinavians and Northwestern Europeans. Around 500 BC, Celtic culture arrived in Ireland during the Iron Age. This represents one of history's most fascinating examples of cultural diffusion without significant genetic impact. Celtic peoples emerged from the Hallstatt culture of Central Europe around 1200 BC. Their heartland lay in the upper Danube and Rhine River regions of what is now southern Germany, Austria, and Switzerland. By 500 BC, Celtic-speaking groups stretched from Ireland to Turkey, from Scotland to Spain. The Celts brought revolutionary changes to Ireland. They introduced the Irish language, which evolved into modern Gaelic. Their distinctive art style, featuring intricate patterns and designs seen in jewellery, weapons, and later illuminated manuscripts, became fundamental to Irish cultural identity. Celtic social structure organised around clans led by chiefs shaped Irish society for centuries. They brought ironworking technology, creating superior tools and weapons that transformed agriculture and warfare. Genetic analysis reveals something remarkable. Despite their enormous cultural influence, Celtic migrants had minimal impact on the Irish gene pool. The Bronze Age genetic foundation remained largely intact. Ireland absorbed Celtic culture while maintaining its existing population structure. In 795 AD, Viking longships first appeared off Ireland's coast. For over 2 centuries, Norse raiders and settlers left their mark on Irish genetics in ways that scientists can now trace with unprecedented precision. The 2017 DNA Atlas provided the first direct genetic evidence of Irish-Norse intermingling. These signatures match populations from Norway's north and west coasts, exactly the regions where Viking activity was strongest. Vikings weren't merely raiders. They established permanent settlements, founded major cities including Dublin, Waterford, and Limerick, and integrated into Irish society through marriage and trade. Archaeological evidence shows Vikings controlled Dublin for over 300 years. The genetic impact varies significantly by region. Coastal areas, particularly Limerick and Galway, show much higher levels of Norwegian ancestry. Some Irish surnames carry distinctly higher Viking genetic signatures, revealing family lines with strong Scandinavian heritage. Modern genetic studies can even distinguish between different Viking populations. The Norwegian signatures in Ireland differ from Danish genetic markers found in eastern England, showing how specific regional populations left distinct genetic fingerprints. The Norman invasion of 1169 AD added another genetic layer to Ireland's complex ancestry. These weren't typical medieval conquerors. They were descendants of Vikings who had settled in northern France and adopted Frankish culture. Norman DNA reveals a fascinating genetic mix of French and Viking ancestry. Their impact concentrated in eastern and southeastern Ireland, where Norman lords established strongholds and intermarried with existing Irish nobility. Unlike previous migrations, we have detailed historical records of Norman settlement patterns. The Normans introduced new architectural styles, legal systems, and agricultural techniques. They built stone castles, established new towns, and created administrative systems that lasted for centuries. Genetic analysis shows Norman influence persisted through intermarriage rather than population replacement. Their genetic signatures blend with existing Irish, Viking, and Bronze Age ancestry, creating the complex genetic landscape scientists observe today. The mysterious Black Irish features that sparked our investigation have a remarkably simple explanation rooted in this complex genetic history. Those Mediterranean characteristics, dark hair, olive skin, and Southern European facial features, trace directly back to the original Anatolian farmers who arrived 6,000 years ago. Their genetic signatures, which scientists confirmed match modern Spanish and Sardinian populations, have persisted through millennia of Irish history. In some families, these ancient Mediterranean genes express more strongly than in others. Combined with Bronze Age, Viking, and Norman genetic contributions, the result is the remarkable diversity visible in modern Irish faces. Regional variations in the Irish DNA atlas support this explanation. Areas with higher concentrations of original Anatolian farmer ancestry show more Mediterranean features. Coastal regions with stronger Viking genetic signatures display more Scandinavian characteristics. The Spanish Armada theory collapses under genetic scrutiny. The 1588 shipwrecks occurred too recently to explain widespread Mediterranean features across Ireland. Moreover, genetic analysis shows no specific Iberian genetic markers that would indicate direct Spanish ancestry from this period. This genetic research extends far beyond historical curiosity. Understanding Irish genetic origins has immediate medical relevance for millions of people worldwide. The Irish population shows unusually high rates of specific genetic disorders: cystic fibrosis, celiac disease, and galactosemia, a serious metabolic disorder preventing breakdown of sugars in dairy and legumes. The distribution of these conditions across Ireland correlates with specific genetic signatures identified in the DNA atlas. For the estimated 20 to 30% of North Americans claiming Irish ancestry, this research provides crucial health information. Knowing specific Irish regional ancestry could affect disease risk assessment, genetic counseling, and even organ transplant compatibility. The genetic differences are significant enough that medical researchers now design studies considering specific Irish genetic subgroups rather than treating Irish ancestry as a single category. The Irish DNA Atlas remains an active research project, continuously accepting DNA donations from people whose 8 great-grandparents lived within 30 miles of each other in Ireland. Each new sample adds detail to our understanding of Irish genetic history. Recent discoveries include evidence of distinct genetic subgroups within known lineages, suggesting even more complex migration patterns than initially recognized. Scientists have identified genetic signatures that may represent previously unknown migration events or isolated population groups. The research methodology continues improving as scientists develop more sophisticated techniques for analyzing ancient DNA and distinguishing between different historical migration events. Ireland's genetic story reveals something profound about human identity and migration. This small island on Europe's western edge contains within its population the genetic heritage of an entire continent. Every Irish person carries DNA from multiple ancient migrations. Anatolian farmers who brought agriculture 6,000 years ago. Bronze Age peoples who transformed the population 4,500 years ago. Vikings who established coastal settlements 1,200 years ago. And Normans who added medieval French Viking ancestry 850 years ago. The Black Irish mystery led us to a far greater discovery. Irish identity doesn't depend on genetic purity or single ancestral origins. Instead, it represents 6,000 years of human adaptation, cultural synthesis, and genetic mixing that created one of Europe's most genetically diverse populations. When you encounter someone with those distinctive Mediterranean features that sparked this investigation, you're seeing the visible expression of humanity's greatest story. Our species' remarkable journey across continents through ice ages and into the modern world. Ireland's genetic atlas proves that our human family tree has roots stretching across vast distances and branches intertwining in beautiful, unexpected ways. The real forbidden story isn't about hidden populations or secret ancestry. It's about how magnificently complex and interconnected human heritage truly is.